I started work on the Frisco by doing some sketches to see what it might look like, but I very quickly reached a point where I needed to actually try a glove in a tube, try inflating it. So I just got a bit of old pipe and connected it up to a couple of vacuum cleaners. It used much more air than I was expecting. My original drawing, using 9 gloves, was obviously over-ambitious. Designing a machine isn't just a matter of doing drawings. The trial and error process, messing around with prototypes, is an essential ingredient. For the last year, I've been working for the Science Museum in London, building a new gallery called The Secret Life of the Home. Just at the moment, we're making a series of surreal objects to hang from the ceiling. And I've just started working on an iron that I'm going to get to work upside down on its ironing board, moved backwards and forwards and held up by a magnet.
I thought one would support my weight, but it didn't quite, and I nearly knocked myself out on a bit of metal, but with 2 I can quite comfortably lift myself off the ground. Whoops.
Just. I've cut out a bit of plywood for the ironing board with a slot in it for the magnet, and I've got an old door gear from a sliding door here, and I'm going to use this to support the magnet with the iron underneath. So the next thing I've got to fix the magnet to the door gear. I don't want to weld the magnet on, I need to be able to get it off. So I think I'm going to have to weld a flat plate on here and then bolt it into these holes somehow or other. How much space have I got in there? I need a tape. I usually design all the details for these bits and pieces as I go along. It's much easier to see what shape and how strong it should be if I've got the rest of it, the part finished machine, in front of me. I sometimes do a sketch when something's more complicated than this, but I still often change my mind when I'm actually making it. I think what I'm going to do next is drill the holes through there. I think maybe the next thing is to tack weld the this new bit of metal onto the stuff that's already there. Just press and squirt, really. Oh damn, I'm going to put these bolts in the wrong way. I won't be able to get them to bits again. I suppose if I'd drawn all this out, that would have done a proper engineering drawing. I wouldn't have had this problem, it's true, but it's not actually a big setup. Is that better? Bit better. Yeah, I think that's all right. Now I've got my magnet moving up and down on the door gear. I've got my wheels under the iron with a bit of metal to be magnetised. So if I pop it under, that's sort of it. Now it should move along together. It doesn't work. This is the sort of problem that would never have shown up on a drawing or even on a computer model. But having all the parts in front of me, I not only see the problem, I can now, it does make it a lot easier. This is a good starting point to find a solution. My approach may seem rather haphazard and not part of the modern world. However, I've gradually realised it's actually not possible to design any machine even sophisticated mass-produced ones, without a lot of trial and error. Black & Decker are just completing a 2.5-year process developing a new range of cordless drills.
The name of the game is to try and avoid making hundreds of thousands of products that don't work. There are a large number of new parts in any product like this, and at some stage all of them have to be prototyped. This is a model of a gear changer, which we have developed only this block to show how the switch feels and how it sounds. And if I can just open it up. This prototype is only to develop the shape of this ramp, and this is the sharp click that we wanted to end up with. You could end up with a series of prototypes that don't work, but at that stage you haven't lost very much. You can always go back and rethink it and make them again and try a new concept.
Although Black & Decker make extensive use of computers, the designs of the prototypes still start with hand-drawn sketches. The engineers say they find it difficult to think of every aspect of a design while in front of the screen, and still prefer to use traditional pencil and paper.
After the paper design has been done, the first thing every engineer wants is to see the parts for real and how they look, and make judgments about how strong they are and whether they're going to work. It's not possible to do all that off pieces of paper.
Designing machines in detail on paper is a surprisingly recent idea. These are some of the earliest engineering drawings from about 1800 in the Science Museum library. The engineer obviously took great pride in them, colouring them in beautifully. Designing by drawing obviously increased the status of an engineer, proving that they could design intellectually without getting their hands dirty. Some engineers remain sceptical. Naismith, the great 19th century engineer, wrote, "The eyes and fingers, bare fingers, are the two principal inlets to trustworthy knowledge in all the materials and operations that an engineer has to deal with. Hence, I have no faith in young engineers who are addicted to wearing gloves. Gloves, especially kid gloves, are perfect non-conductors of technical knowledge."
Design engineers today don't generally get their hands dirty. Prototypes are made by specialist model makers from the engineer's drawings. However, at Black & Decker, the initial prototypes, to demonstrate potential products to the management, are still made by one senior engineer working with his hands.
So I was asked to put together a strimmer that had lots of features in it, so that you could possibly select from them almost like a shopping list. An easily adjusted handle, I thought was one of the easiest things to do. So I mean, this was very simple to build. And I've just shown the standard saddle clamp off a mountain bike.
Oh, yeah.
So I added some extra wheels, so they pop down like an aircraft undercarriage, and they go nice along the side of the grass. You can see one of the problems of prototyping is you're building things. I mean, it was actually built in this position, but when you get to the retracting position, there was a slight interference with the outer guard.
Yeah.
So hence the two almost Mickey Mouse-like ears. I mean, that was done in 3 days. If I was to sit down and try and design each part of that and then do a formal drawing, we're going to have a much longer time scale. And it's much easier to actually build the components. Because normally, as you're making one component, as you may be perhaps milling this component here, your mind, although you're actually milling that, your mind's working on the next interface. I mean, sometimes you get it wrong, as these ears demonstrate.
Yeah.
I never thought about them till I came to fold it back, and then obviously got a problem. And occasionally we might have to start again with a slightly different route.
Yeah.
But at least you've proved that route's dead.
Yeah.
So even a failure is a success.
I've now got a bit further with my iron. I've now got a row of 5 magnets of alternating poles. I put them on the iron itself this time. They're only tiny, but they're these rare earth magnets that are incredibly strong. I can't get it off. I know if I trap my finger between two of them, I get a blood blister. And they go on there. And I've also added a motor and a chain. And this drives the door gear backwards and forwards. Unfortunately, I still don't think it's really quite right. It's moving in horrible jerks. It's marking the ironing board, which rather gives the game away, and it still falls off sometimes. I also think it looks a bit dull. I think what I'm going to do is I'm going to actually have to start all over again. But this isn't defeat. The whole point of the trial and error prototype process is to find out about the problems. I made a new linkage to make the movement less jerky, fitted even stronger magnets, made a new frame to make the surface of the ironing board less uneven, and finally added a shirt.
There's a booklet that accompanied the series. For a copy, please send a cheque or postal order for £2 payable to Channel 4 to Machinations, PO Box 4000, London W3 6XJ.